Hello and welcome to yet another video of Cornerstones of Math. In this video, I am going to explain one of the cases where students frequently use the wrong method to solve the problem. It says, for a sequence an defined by recurrence relation, the first term a1 is 1, and an plus 1 is given as 2/3 times an plus 2/3 for all natural numbers n. Find the limit of an as n goes to infinity if it exists. Like I said, many people take the wrong approach to the problem, so let me explain the wrong method first, which is, in the end, we want to find the limit of the sequence, so let limit of this sequence an be alpha. Then, if we take limit on the given recurrence relation, it becomes alpha equals 2/3 times alpha plus 2/3. You know, owing to these properties of limits that you're all very familiar with. This further simplifies to 1/3 times alpha equals 2/3, which gives alpha equals 2, hence the limit of the given sequence must be 2. And we're done, right? Well, this is the correct answer, but it is obtained by the wrong method. That is, the process demonstrated here is not a logical process. So what was the problem? Well, we cannot use this method because the question originally given in the video was this. Find the limit of an if it exists. But we don't know that such limit exists yet. We don't know that the given sequence actually converge, for now. I mean, this first process of taking the limit on the recurrence relation is wrong, because this process relies on the aforementioned properties of limits, which only works if both limits alpha and beta exist. That is, both sequence an and bn converge. But since that is not guaranteed for our sequence an, we need to search for another method, the correct method. To solve this problem in a logically correct method, we have to actually solve the given recurrence relation and obtain the expression for its general term. Luckily, this is a rather simple and very famous type of recurrence relation, where its solution is also well known. The method to solve the recurrence relation of the form an plus 1 equals pan plus q is, we change the given relation into the form an plus 1 minus alpha equals p times an minus alpha, and use that the sequence an minus alpha is a geometric progression with common ratio p. To apply this to our given relation, let us change the given recurrence relation into the form an plus 1 minus alpha equals 2/3 times an minus alpha. This simplifies to an plus 1 equals 2/3 an plus 1/3 alpha. If we compare this to the originally given recurrence relation, we know that alpha equals 2, which happens to be the value that we obtained previously from the wrong method. Coincidence? Well, you think about it after watching the entire video. So we know that the recurrence relation becomes an plus 1 minus 2 equals 2/3 times an minus 2, and we can use the fact that sequence an minus 2 is a geometric progression. So its general term an minus 2 is given by first term a1 minus 2 times the common ratio 2/3 to the power of n minus 1. Here a1 equals 1, so the constant in the front becomes negative 1, so we have negative 2/3 to the power of n minus 1, which gives the general term an equals 2 minus 2/3 to the power of n minus 1. And if we take the limit, this part tends to 0, so we obtain the limit value of 2. And this is the correct answer obtained by correct method. But the wrong method gave the same answer too. So can't we just use the much simpler wrong method instead when we don't care about the correct process and only care about the answer? Well, the thing is, this wrong method doesn't always give you the correct answer, and here I will give you one example for that. It is the sequence defined by the recurrence relation a1 equals 1 and an plus 1 equals 2an plus 1. You can already easily notice that the limit diverges because the recurrence relation implies that this is the sequence that increases faster and faster. However, if we try to use the wrong method and let limit of an be alpha, we obtain alpha equals 2 alpha plus 1, hence alpha equals -1, which is the wrong answer by the way. The correct method is to find alpha that satisfies an plus 1 minus alpha equals 2 times an minus alpha, which also gives alpha equals -1 by the way. So we have an plus 1 equals 2 times an plus 1, and sequence an plus 1 is a geometric progression. So the general term an plus 1 is given by first term a1 plus 1 times the common ratio 2 to the power of n minus 1. Here a1 equals 1, so this simplifies to 2 to the power of n. Therefore, an equals 2 to the power of n minus 1, hence we know that the limit goes to infinity, that is, diverges. So the conclusion of this video is, do not hastily assume that the limit exists and take limit on the recurrence relation when the convergence of the given sequence is not guaranteed. And that's all for today's video. Now here are some other cases where students are prone to make mistakes in terms of mathematical logic, so feel free to check out these videos as well. Also, please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.